Alright guys, we are on day 2, Venn diagrams. Alright, so what we're going to learn about today is some more about N and R and how to create Venn diagrams to help us to find probabilities, how to read Venn diagram from probabilities, and what the symbols OR, which means union, intersection, which means and complement, which means not. And I'll show you what those symbols are. Okay, so a union means and it looks like the symbol this. So you may have a probability to show up. Oh wait, I'm sorry. It doesn't mean and. My apologies. Union means or. And it may show up, it looks like this. And it may show, and it'll show up in a problem like this. A or B. Or the people might write it as, whoever's asking you a question may write it like this. So that's what union means. It means or. Intersection means and if you think about intersection, it means where they both meet at. That's what the word intersection means. And here's how I remember it. And has that N in it. So here's the symbol. It looks like an N. So you do the probability of A and B, or the probability of A and B. They can write it either way. Oopsie, there will be. Okay, complement, and there are lots of ways people write this. Complement means not, and there are ways it can be written. It can be written as not A and not B, or it can just be written singular. This little symbol up here means not. You can put it as probability, and normally if it wants both like that, they write it as not A and B, and then they put a little apostrophe up there for for not. Another way that it can be written is with the little line on top, or people may write it, if it's a compound event, they may write it like this, but they all mean not. And of course, you know, these ands can be ors, or they can be any of these symbols. You just put the little apostrophe, and if they want one and not the other, then they'll put the apostrophe on not one but and the other. For an example, not A or, but we want the regular probability for B. Okay? A Venn diagram is a way to organize data to find probabilities. Alright, and normally you'll see Venn diagrams like this, where the middle is the intersection, and then these here are the separate ones. On the outside is what's not a part of the two bubbles. And sometimes you get 3 of these, you get 4, they all mean the same thing. Okay? So let's dig in here. Okay, so here's an example. What do you notice about the two pictures? So here we have a bird and here we have a bat. So our two bubbles are bats and birds. Okay, what they have in common is in the middle. That's called the intersection. This is, they have wings in common and they eat insects. That's in common. Now, characteristics that only belong to the birds is that birds have feathers and lay eggs. Now, characteristics that only belong to the bat is that bats have teeth. They sleep upside down. And the characteristic that does not belong to either one of these birds or bats is that they have 6 legs. This is what we would say to complement. Now, what is the total sample space here? How many objects do we have in this situation? There's 1, 2, 3, 4, 5, 6, 7. Well, 1, 2, 3, 4, 5, 6, 7. There are 7 characteristics here with this situation. All right. Let's keep moving. It says how many traits belong to the bats or the birds. So in that first one, if I wanted to write that, what are the characteristics that belong to the bat? How many characteristics belong to the bat or the bird? So we're going to go count. Or means all of these added together. So there's 1, 2, 3, 4, 5, 6 characteristics that belong to the bat and the birds. Now notice these 6 legs do not. So the second answer here, it says how many traits, so we can write 6 here. How many traits belong to the bats and the birds and the bats? Well, this is what they have in common. There are 2. And then here it says how many traits do not belong to bats or birds or bats. Well, that's this down here. There's 6 legs, so there is 1. Let me erase this down here. Okay, so that's how you read a Venn diagram. So now let's go answer some questions involving this. It says all of the characteristics in the Venn diagram are written on a sheet of paper and put in a bag. Answer the following. So let's go ahead and knock out number 1. It says, what's the probability of pulling a characteristic of the of the bird? So we have 2 characteristics of the bird. So probability of the bird, and I'm going to say BI, is going to be 2. Has 2 characteristics, and how many objects are in this bag? There's 1, 2, 3, 4, 5, 6, 7. So 2 out of 7. All right, let's do number 2. It says, what's the probability of pulling the characteristic of a bat? Well, we have 1, 2 characteristics of a bat. Well, let me write that. I'm going to say probability of a bat. I'm going to just call it B. 1, 2. So that's 2 out of 1, 2, 3, 4, 5, 6, 7 objects that are in this bag. Okay, also for number 3, what is the probability of pulling the characteristics of a bat and a bird? So probability of a bat and a bird would be equal to, well, it's something that they have in common, wings and eat insects. So that will also be 2 out of 7, because there's 7 things in that bag. Okay, so number 4, what's the probability of pulling the characteristics of the bat or bird? So the probability of getting a characteristic of the bat, probability of the bat, and now this time I'm going to use the union symbol instead of the intersection, because this one's or. So how many objects do I have in here? I have 7 in all. And what's the probability of pulling a characteristic of them both? 1, 2, 3, 4, 5, 6. A bat or a bird. So there are 6 characteristics there. And it said, what's the probability of not pulling a characteristic of a bat or a bird? So now that was a not question. So probability of not doing this. So I'm going to put the not symbol on the outside. And the only thing, that's 1 out of the 7. And we're finished. Okay, so really just read carefully, write your symbols, and go for it. All right, let me see if we have another practice one. Yep, there's another practice one. It says you have 3 people with bowls of ice cream, and one has chocolate, one has vanilla, and one has both chocolate and vanilla. Here are some questions for discussion. All right, so if I want to figure this out, I'm going to draw a Venn diagram. So I have 1. This is my vanilla. And since a person has both in there, I'm going to go ahead and draw where they loop together. And here is my chocolate. So I have 1 person that has vanilla, 1 person. And look, babies, when you do these Venn diagrams, always do the middle one first when you're giving numbers, so that way you can figure out the rest of them. It says 1 person has both chocolate and vanilla. Okay, 1 person has vanilla only, and the other person has chocolate. So here we go. Here go our 3 people. It says how many people have vanilla ice cream? So we have 2 people that have vanilla ice cream. How many people have chocolate ice cream? We have 2 people that have chocolate ice cream. How many people have chocolate and vanilla? We have 1 person that has chocolate and vanilla. Is the correct answer to how many people have chocolate or vanilla ice cream 2 or 3? So it's saying how many people have chocolate or vanilla ice cream? Is it 2 or is it 3? That is interesting. So, how many people has vanilla or chocolate? Well, how many people do we have in this situation? 1, 2, 3. So the answer here is going to be 3. There are 3 people that we're dealing with in this situation. We want to know all of them. Now, normally when we have these do I talk about that here? Well, no, I'll leave it alone. I'll talk about dependent events in a minute. So go ahead and go to Canvas and make sure you do day 2 of week um of April 20th. And see you guys at 12 or yeah, I'll see you guys at 12 today. Bye.